So continuing on in lesson 1.4, what is our third objective in lesson 1.4? Braden?
Simplifying before solving equations.
Simplifying before solving. Now, there's a difference between simplifying and solving. Simplifying is something you just do on one side. But remember, when we're solving, we have to do it to both sides. And that kind of confuses students sometimes. They think, if they're simplifying, they get that mixed up with keeping the equation balanced. And there is a difference. So sometimes we're going to have to simplify one or both sides before trying to solve it. It's going to make life a lot easier for you. The simplifying steps include, and there's no special order to this, combining like terms, so you're looking on the sides of the equation and you're looking to see, are there any like terms that I can put together first before I start trying to solve this? And or distributive property. Those are the two simplifying steps that can happen in an equation before you try to solve it. So we're going to today, we're going to be looking for, do I need to simplify either side or maybe both sides of the equation before we start to do the solving part, then doing the same thing on both sides. Okay? So let's look at our first problem here. Typically, what I like to tell students to do, and if you were successful with this in the past and you don't need to do the change subtraction to add the opposite, feel free to not do that. But I'm going to recommend that you do it. So first thing I'm going to do with this equation before I even try to simplify is I'm going to take any subtraction that's in it and change it to add the opposite. So minus 21 is going to become add negative 21. Minus 5x is going to become add a negative 5x. So here we're just renaming the subtraction as addition. Then we can look to see, first of all, is there any distributive property to do? What is distributive property? What am I talking about when I say distributive property? In order of operations, does anybody remember the complete order of operations? What's the first thing you look for in order of operations? Parentheses. And what does that mean? What do parentheses mean? You just look for them and then if they're there, you just get rid of them? You drop them? Hey, Courtney, what does it mean?
You do what's inside the parentheses.
You do what's inside the parentheses. You simplify what's inside the parentheses. That's a way to get rid of them. Okay? And then it says, what's the next order of operations if we're exponents? So you look to see if there's any exponents to take care of. And then what's next? Multiplication or division from left to right. And then last, adding and subtracting from left to right. Okay, well, parentheses. What if inside those parentheses it's something like 4 plus x? Can you actually add 4 to x? No, you can't really do what's inside the parentheses. Well then, to get rid of the parentheses, you're going to have to look out front and see, is there some multiplying? Is there a number in front that you have to do to help you get rid of the parentheses? That's when we do distributive property. We multiply over the parts of what's inside the parentheses. That's how we can get rid of the parentheses. So distributive property is really multiplication over subtraction or addition. Combining like terms means you can put together things that are alike. Can x's be added to other x's?
Yes.
Yeah. Can x's be added to y's? No. Because they stand in for two different things. We can't combine them. So what can we combine on the left side of this equation? The 8x and the negative 5x. So what does that become?
3x.
3x, because you got 8 of them plus a negative 5, we have 3x. And there's nothing on the left side to combine with that negative 21. So everything else, that's the only simplifying. So all we did here is we did some simplifying. That's all we did. We simplified. We added like terms. We're not solving it yet. Can we solve it now? Do we have any other simplifying to do? No. Now is when we say, okay, now I need to get x along. So what's going to be our first move? Add 21? Yeah, add 21 to both sides. So now we're starting to solve. Now we're starting to solve. And we have 3x on the left side now and 6 on the right side. Okay, and next we will divide by 3. Do you notice how I always take the thing we're going to divide by and I write it again? Because then I can see that from my previous step, here's what I got. And now I'm taking what I got and I'm going to divide it by 3, and then I can follow my process better. Some of you try to cram a whole bunch of stuff in one spot, and then when you're trying to explain it to yourself or me or anybody else, you can't. Those cancel out and we have our solution, which is x equals 2. Okay. If we did do a check problem, we'd have to put 2 in both places here, right? Have to go here and it'd have to go there. And you always check, hear me carefully on this, because if you're checking, let's say you're on the quiz and you guys want to stay eligible for football, a play, whatever it is, and I give you a quiz and it's the only grade you have in this class and you failed that quiz, that makes you ineligible. It only takes one class and I would hate for that to happen. So it would be in your best interest to check your work even if I don't require it, right? So if you're going to check these problems, you have to check it. Go back and check it at the beginning. Because if you made a mistake along the way somewhere, let's say that you want to check it in this one right, this part right here, where you, after you did your simplifying, if you simplified it wrong, then you're going to get the wrong solution. But your wrong solution is going to check out in your wrong simplifying. Of course it is, because you know how to solve. So we have to go all the way back to the beginning to do our checking. So let's just do it mental math. 8 times 2 is 16. Minus 21 minus 5 times 2 is 10. And that's supposed to be negative 15. Okay, let's check it out. 16 take away 21. 16 above 0 drops 21 degrees. Negative 5. Drops another 10 degrees. Negative 15. This does become negative 15, just like the other side, so it checks out, doesn't it? So, again, when you do check problems with problems that you had to do some other stuff to the equation first, go back to that equation you started with. Don't be lazy and go about halfway down and check in that, okay? Any questions? Okay, then let's go down to that bottom one. Can we combine what's in those parentheses? No. So we have to do distributive property. Now again, before we even do that, I'm going to suggest, because this too is where students get in a lot of trouble, when there's subtraction involved in distributive property. So the first thing I'm going to do is I'm going to change this to an add the opposite problem. You know what, I'm even going to slip a 1 in there. Because a D is a 1D, correct? And the opposite of 1 is negative 1. So there we're just like making it more friendly, user-friendly. Now we're going to do what's called distributive property. We're going to take the negative 2 times each piece in the parentheses, right? So negative 2 times 3.
6.
Negative 6. Plus negative 2 times negative 1. Positive 2, and those are D's. It's kind of like saying we have, 2 groups of 1D. So we have 2D. We just simplified. That's all we did right there. We just simplified. We're not solving yet. We're just getting it ready to solve. Now it's an easy one to solve, right? Go ahead and solve it. You know how. Do you agree with me? Yeah, thumbs up, okay? Let's check it out. Let's just do some mental math check. 3 take away 5. That's our solution, right? 3 take away 5. 2. 2 times negative 2.
4.
4. 3 take away 5 is, what did we say? Negative 2, did we say that? Okay. Negative 2 and negative 2 times negative 2 is positive 4. We're good. We got what seems to be a good solution, right? Okay, flip over then. Let's go try another one of these before we do I believe, what, an application problem maybe?
Yep.
Okay. This one, what do we want to do first? Parentheses. But before we do parentheses, change to add the opposite. Yeah, let's get this cleaned up. Let's get it more friendly. 2 times x plus 2. No subtraction going on there, but there's subtraction here. So we're going to, and some of you, you're like, I don't need to do that. That's, that's cool. If you don't think you do, and you keep getting correct answers, then you can stay on that, that wagon. But if it doesn't work for you, you keep getting wrong answers, or every now and then, especially ones that have a lot of subtraction in them, those seem to be the ones tripping you up, and you need to probably do this extra step here. Okay, now we're ready to do our distributive property. 2 times x is 2x. Plus, you always bring down the sign that's in between the parentheses there, right? 2 times 2? 4. Plus a negative 4x equals 40. Is that a simplifying step or a solving step? That's a simplify step. Okay. Do we have any more simplifying to do?
Oh, yes.
Yeah, on the same side are these guys. Now students like to think that this is what they need to do, that they subtract 2x from both of these pieces. That would be doing the same thing twice on the same side. Does that make sense? Does that keep an equation balanced? Doing the same thing twice on the same side? No, it doesn't, does it? So you're not really subtracting 2x to get it out of there and then doing it here, because that's not two sides of the equation. You're just combining these guys and saying that all together, if I have 2x's and a negative 4x's, how many do I have? Negative 2x. And again, all we did was simplify again. We're still not solving. Sometimes it takes 2, 3 simplifying steps to get it ready for you to solve. Okay, go ahead and solve that. You know how. I want you to, yourself right now, I want you to do a mental math check all the way back in the beginning of this problem. So before we even simplified, before we changed it to add the opposite, do a mental math, use your calculator, whatever, figure out if negative 18 is a good solution or not. Do we like it? to check out, did you? I'm looking up. Do you see I substituted in? Here's where I substituted it in, right here. And then I worked my way up. See if it checked out. Again, do we want to make sure we're getting these columns correct? Anybody have questions? Anything about any of these three that we've done that we've left you behind? You're like, in a fog, you're like, I want to know why we did this. You need to ask. It's okay. I don't charge you any more for asking than not asking. Your education's free. Hannah.
Is it okay if we do it a little different if we still get that same answer?
It is okay if you do a little different if you get the same answer. The only thing I might ask you to do is, like sometimes just show it to me and so I can just see how you're doing it and see if it looks legitimate. Because there can be other ways to go about solving it, definitely. Okay. Anybody else? So yes, there are other ways to go about solving or maybe doing it. And of course, I'm showing you every single little possible step in our notes because we want to have good, clear understanding of and steps to do it. Okay, it's in your homework. You're going to have some geometry problems that have some algebra in them. So it says write and solve an equation. Oh, did you get that? Write and solve an equation. So here's the part that you guys are going to not do. And write an equation to find the value of x. Well, that means there better be an x in your equation, correct? In the triangle shown. Okay. The sum of the angle measures in any triangle is what?
Like 180 degrees.
180 degrees. You can count on that all the time. I don't care how small that triangle is, how big that triangle is, if it's an acute triangle, an obtuse triangle, a right triangle, whatever it is, it will have all three angle measures will add up to 180 degrees. Okay? Well, then, since we know that, and they gave us a picture with some angle measures, anybody think they know what kind of an equation we could set up here to help us solve for x? That's what we're solving for. It says solve to find the value of x. The sum of all the angle measures in a triangle is 180 degrees. McKenna, you think you got it, or are you thinking with your hand resting? No? You don't know? Or you want to try? So can you tell me what to write down?
This is the 2x minus 4, and then plus 25.
Keep going, I like
Plus
it.
57 equals 180.
There you go. As painful as it was, you're right. The three angle measures added together should be 180 degrees. And the angle measure for the one was given in parentheses. How do you feel about those parentheses? Are they important, Abby?
Can't we just put an X there instead of the whole parentheses?
Can't we just put an X there instead of the whole parentheses? So put an X in place of the 2x minus 4?
No, just like have X plus 35 plus 57.
No, we can't.
Can't.
No, because this angle measure is not just X, it is double X take away 4. So no, we cannot do that. Does anybody know why those parentheses? You know what role they're playing there? Because that's another thing that we have to get really good about understanding. What do the parentheses do? Or do they have to be there? Can I get rid of them? When do I need to use them? When I'm writing my own equations? How do you feel about those parentheses? What do you think their role is? Jacob?
So that they can group specific parts of the equation so that it makes more sense, because if they didn't have the parentheses, you could add the opposite, make 4 negative 4, and then you could add 35 and 57 and -4 together, but then you wouldn't get the right answer.
Oh, you don't think we get the right answer if we just, so he said, the parentheses are there so that we know that we need to change that to add the opposite. And then if the parentheses aren't there, then we would add the 35 and the 57 to the -4 and we'd get the wrong answer. What do you think? Actually, we wouldn't. Parentheses are used for a variety of reasons. It's to show multiplication, right? They're used to show multiplication. They're also showed, in this particular case, they're playing this role. They're showing that this whole value, this whole expression is degrees. That's all they're doing. That's the only purpose for those parentheses. It is showing that this whole value, 2x minus 4, when you know what it is, it will be measured in degrees. So in reality, we can cross off those parentheses. We don't need them. They're unimportant in our equation. So now, we are going to write this as 2x plus a -4 plus 35 plus 57 equals 180. We got rid of the parentheses, we changed our subtraction to add the opposite, and we decide, are we ready to solve, or do we need to simplify first? Simplify. We have some like terms, don't we? What are they? 35, 57, and -4. Those are all like terms. They're all constants. They can all be added together. So 2x doesn't have anybody to be added with. -4 plus 35, that is 31. 31 plus 37 is 31 plus 30, or 57 is, sorry, I think I said that wrong. 31 plus 57 is 88. Oh, word. Oh, those calculators have been so handy, haven't they? Okay. We have only simplified it so far. Are we done simplifying? Can we do anything else? Can the left side be simplified anymore? Does the right side need any simplifying? No, we're ready to solve. So go ahead and solve this equation for x. Stretch yourself, see if you can, process through what is 180 take away 88 without a calculator. Did you get what I did? Anybody?
Yes.
Okay. Now, here's what you do though. You always go back and you see what were you looking for. Let's make sure this is our final answer. Because sometimes you think you're done, and here's, so we got to go back up and see what were we solving for. It says write and solve an equation to find the value of x in the triangle. Are we done?
No.
Did we find the value of x?
Yes.
Yes, we did. We're done. It's 46. What if, though, what if they had said write and solve an equation to find the value of the missing angle measure in that triangle? What's the angle measure we don't really know? The 2x minus 4. We don't know that, do we? We know it's 2x minus 4. We don't really know what it measures, though. So if they ask that, then we'd have to do one more step, wouldn't we? We'd have to put 46 in for x, double it, and take 4 away. And then we would say, oh, the missing angle measure is 88 degrees. Okay? Let's see if 88 plus 35 plus 57 adds up to 180. It's 88 plus 35 plus 57 adds up to 180.
Yep.
So what I'm trying to point out is we got to really make sure that we take the time to go back and look at what was it they were asking us to find before we say, I'm done. Okay? So any questions on this problem? Because yes, you have some like this to do in your homework for Monday.